All right, so we pick back up with our PowerPoint where we left off yesterday at the moving on. Now this is where I've been telling you that it becomes like a Sudoku puzzle. You change one thing and it can change two or three, but that's what we have to go through to balance equations. Chemical equations express what is happening in a chemical reaction using symbols. We've talked about that. We've got reactants on the left. Our arrow means yields. And then our products are on the right. Our reactants produce products. That's a chemical reaction. The law of conservation of mass says in a chemical reaction, matter cannot be created or destroyed. It can only be changed. We change the way the atoms come together to form different compounds. We talked about sodium by itself ain't good for us. Chlorine by itself ain't good for us. But sodium chloride is good for us. That's salt. The body needs salt to survive. Now, when we have a chemical reaction, we can combine salt. If you put salt on metal, what does metal do? It rusts. It melts ice. Okay? There's chemical reactions taking place. Okay? The atoms are recombining to make other substances. When we pour vinegar on baking soda, okay, we get a gas. It takes atoms from the vinegar, atoms from the baking soda, they recombine to form a gas. That's our chemical reaction. Okay? They recombine. Therefore, the reactants and products must equal from one side to the other for our equation to be balanced. Science does not like unbalanced things. Chemistry doesn't like it at all. You have to be balanced when you're working in a lab. If not, you don't get the results you're expecting, and sometimes that can be dangerous. The reactants must contain the same elements and the same number of each element as the product, but they can be in different compounds. But you can't add atoms to products that don't exist in the reactants. You can't create a new element out of elements. Those are compounds. So if you start with oxygen and hydrogen with water, what's the only two things you can finish with? Oxygen and hydrogen. That's it. Nothing else can be a product. H2O2 yields H2O. Is that possible? No. Because on our reactant side, based on what we know about counting atoms now, we've got 2 hydrogen and we've got 2 oxygen. But on our product side, we've only got 2 hydrogen, but 1 oxygen. Now the law of conservation of mass says what? Matter cannot be created nor destroyed. It changes its where it's at, what its state is. But so we look like right here we've lost a what? We've lost an oxygen atom. Well, we can't lose it. We got to find it. Or we got to change our equation. The chemical equation must be written according to the law. On the test, you will be asked to look at 3 or 4 different equations, and you will have to identify which one satisfies the law of conservation. You may also be asked to balance an equation. What numbers do you change? We know now that we can only change the coefficient, but you may be asked to do that, to actually balance it. Okay? Either one is easy if we count our atoms and then we go through the process. So we've got H2 plus O2 yield H2O. That's the production of water. Okay? It actually happens in nature. We can make water, but it's a violent explosion and it's not a good process. So in order to balance that equation, we need to get the same number of atoms on each side of it. So if we add a 2, coefficient of 2 in front of hydrogen 2, what does that do for us? Well, we now have 4 hydrogen and we have 2 oxygen. We got our oxygen back, right? If we add that same 2 to our final product, we get 2 H2O. And if we count the atoms, we have 4 hydrogen and 2 oxygen. So is that equation balanced? Yes. Is it always going to be that easy? No. Okay? Just like yesterday, we start with the easy stuff, and then we get to the more realistic stuff that we deal with on a common basis. Do I need to know how to balance? Not yet. You need to be able to recognize if the chemical reaction follows the law of conservation of mass. Na plus O2 yields Na2O. Does that one follow it? Does it? No. Mg plus 2HCl yields MgCl2 H2. Does that one follow it? Yep. Okay. How many Mg's I got on the left? How many I got on the right? 1. How many hydrogens on the left? 2. How many hydrogens on the right?
Oh, I see now. Okay.
2. How many Cl's? 2. How many Cl's? 2. This one follows the law of conservation. It simply rearranged the what? The atoms. Okay? Mg hooked up with Cl. And H went solo. Okay? HCl broke up, Mg moved in. Okay? Got a brand new girlfriend. Went and jumped off the deep end. All right? Nope. Yup. So, first one didn't because we had 2 NAs on the product side, but we only had 1 sodium on the reactant side. Let's practice here. How many HGs do I have? How many O's? Over here, how many HGs? How many O's? Is it balanced? Nope. Here, how many nitrogens? How many hydrogens? How many nitrogens? How many hydrogens? 6. That one balanced? Yep. How many zinc? How many hydrogen?
2.
How many chlorine? How many zinc? How many chlorine?
2.
How many hydrogen?
2.
Is it balanced?
Yeah.
Good job. How many potassium? How many bromine? How many potassium? How many bromine? Is it balanced? Nope. How many iron? How many oxygen? No. 2. That plus sign stops that 2. Remember that the plus sign stops everything. Kind of like 2 plus 2. They don't, or 2 that's a brick wall. So how many oxygens? 2. How many iron? How many oxygen? Is it balanced? No. How many sodium? How many hydrogen?
Teachers, please pause this interruption. Bus 120 has just arrived. Please admit your students to class. Thank you.
So how many hydrogen? How many oxygen? How many sodium? How many hydrogen? 4. You got to look for your whole equation. Well, I got 2 of that one. And then I've got 2 over here. That makes 4. And how many oxygen? So is that one balanced? Yes. Okay? Remember, when you're balancing equations, only put your element down one time. If you forget to do that and you've got an H and an H that you're trying to work with, you will have a nightmare. Because you're not looking at individual molecules, you're looking at individual elements. That's what you're trying to balance. So has everybody got that?
Yeah.
So now we're going to go back to balancing. We had 2 hydrogen, 2 oxygen, 2 hydrogen, 2 oxygen. Well, we know automatically that we've got to get 2 oxygen, right? So we're going to put a 2. What do we multiply by 1 to get 2? 2. So we're going to place a 2. Now the oxygen is in balance, but the hydrogen is not. So what do we multiply by 2 to get 4? 2. Change the coefficient. Okay? You got to go. Because if you change here, you may have to come back and change over here. It's just about going through the steps. Now it's balanced. Congratulations. You have learned the hardest thing we will do all year. Huh? You think that's not hard?
I think it's a bit hard. I think it's going to get hard.
It's different, right? You've not seen it before, which makes it a little harder. Think how much you've learned in the last 3 weeks about chemistry and the periodic table and stuff that you were having a fit over if I'd have given it to you to start with. But now that you've seen it and know it, it makes some sense, right? Let's practice here. How many mercuries do we have? Hg. 1. How many oxygens? How many on the product side? How many on the oxygen? 2. So we got to make some changes. We got to get 2. We got to get 2 oxygens over here, right? So if we put a 2 here, then we're going to have 2 what? Mercury. But how many mercury do we have over here? 1. So what do we need to put here? A 2. If we put 2 and 2, then we are balanced. Let's look at potassium. How many do we have here? How many bromines? How many potassiums here? How many bromines? 1. How many do we need? So we put a, but that makes us have 2 potassium. So what do we come back over here and do? Put a 2. How many nitrogens? How many hydrogens? How many nitrogens over here? How many hydrogens? 3. I've got 2 over here, hydrogen. Let's look at our nitrogen. This is 2. This nitrogen is what? 1. What do I multiply 1 by to get 2? 2. So if I put a 2 here, I've got 2 nitrogen, but now how many hydrogen do I have? 6. Well, over here I've got how many? So what do I need to put here? A 3. Good job. How many carbons? How many hydrogen? How many oxygen? 2. How many carbon? 1. How many hydrogen? 2. How many oxygen? 3. 2 and 1 is 3. Don't forget to look at the whole set of products. So now I've got 2 carbon over here. I've got 1 over here. What does that mean I need to put here? A 2. Okay? So then I've got now how many oxygens? 5. Okay? But I've got 6 hydrogen here, 6 and 2 over here. So what do I need to put here? We need to write this down, don't we? Can't do this in our head, can we? Okay? That's my point. Don't try to do it in your head. Write it down. That way you can see it. All right? We're going to stop. Hang on.